Actually, that day it was 1 minute, huh? Yes, I have added you as a co-host. Okay.
Yes, ma'am.
Okay.
Excuse me, ma'am.
No, this class is empty. Hello, am I
Can you
audible?
hear me, sir? Yes.
Yeah, I'm your teaching assistant. I'll be taking this class.
Okay.
If you have any doubt, you can ask. We'll wait for a couple of minutes. We'll start from 6 o'clock. Okay?
Yes, sir. I have a doubt in the practice assignment.
Yeah, we'll be solving practice assignments today.
Okay, sir. Thank you.
Yeah, which question specifically?
Eighth question, sir.
All right, we'll solve that. No issues.
Uh,
Sir,
Yeah.
I'm pretty sure that somebody brought this up in the previous class also, and I'm sorry to bring it up again, but I just thought that it was. I have a doubt in the graded assignment.
Graded assignment.
Yes, sir. So in one question, I'm pretty sure it has something to do with C++, but they have asked us to find the mistakes in that question. And
See, if there is something wrong with the question, it will be corrected after the assignments only. Okay.
all right, sir.
And it doesn't mean that it is wrong. It's for you to find out whether it's correct or not. Till the grade assignments are over, we cannot do anything. Alright?
Yes, sir. It's just there was nothing in the videos that was corresponding to any of that, so we weren't taught about that. I just wanted to ask whether that was the norm or it's
Right now, I cannot make any comment about whichever question you are referring to. Okay. I'm
all
not
right.
seeing the assignments, but then I cannot make a comment right. Alright?
Okay.
Fine. Just a second, I'll just share my screen. Alright. Hope my screen is visible and the, my voice is also fine. If it is okay, just tell me and we can start. Yeah. Tarun, do you have any doubt? Yeah,
My bad, sir. It was my mistake. It was my mistake. My bad.
yeah, no issues. Fine. Hope my voice is clear and my screen is also fine. It is so we can start. Can we?
Yes, sir.
Right. Fine. Okay, we'll solve practice assignments today. Before that, do you all have any doubt with the concepts of record and list? If you have any doubt, you can ask. Otherwise, we can start. Any doubt? All right. Fine. Okay, we'll start with the practice assignments. Week 2. We'll go from the last question, okay? Fine. So basically, this flow chart, it is executed on the shopping bills data set which we have. And we have to read the flow chart and say what the variable count is. All right. Okay. Fine. So, okay. Just somebody respond. No, am I audible?
Yes, sir. You are.
Yes, sir. Yes.
Right. Fine. Okay. Uh, right. Who can just explain what is happening here? Is there anybody who can explain what is happening here with the flow chart? Is there anybody who can explain?
We're counting the bills of Big Bazaar shop where the total amount is less than 1,000. by using iteration.
All right. Fine. Okay. Good. Right. So basically, we are going to start somewhere and we are going to end somewhere. And in between, first we are initializing a variable called count, and it is initialized to 0. It will be updated as and when we pick the card and move the card. Now more cards are there in pile 1. This is just a condition to see if we don't have any more card, we can stop. For that only we have this condition, and if we have more cards, we'll go. When we go in, we pick the card and we move the card. So whatever happens in between is for a given card, and we are going to do it for every card. Now there are two conditions here. First thing is the shop should be Big Bazaar and the total should be less than 1000. In between we have AND operator. The first thing is Big Bazaar is the shop name Big Bazaar and is the total bill less than 1000. Okay. So the thing is we have two Boolean conditions. Okay. This is one thing and this is another thing. And for the entire thing to become true, both has to evaluate to be true. The first one should become true and the second one also has to become true. If both are true, true and true will evaluate to be true. Even if one of these two conditions fail, it won't be true. Am I right?
Yes, sir.
Yes? Yeah. Hope you people know this, right? True and true is true. True and true will evaluate to be true. True and false will become
False.
false. And what about false and true?
Still false.
Yeah. And false, it's obviously false. Right? So based on that, that is how this is there. So if both the conditions are true, we'll go and we'll increment the count. Right now it is 0. From 0 it will become 1. And then if we see one more card which satisfies these two conditions, then we'll increment it from 1 and 2. This is just basically we are going to increment. Okay. So now going to the shopping bills data set, we'll go one by one. All right. So this card is first card we are going to pick. Now this card is not Big Bazaar, am I right? So the condition is going to fail definitely. Since it is not Big Bazaar, this first condition is failing. And since we have an AND operator, the entire condition is overall it is going to become false. So we'll go like this. We'll directly bypass this step and we'll come here. All right. So this is for the first one. And the second card is Big Bazaar, but then the total amount is not lesser than 1000. It is 1525. So this time the second condition is false. So similarly, the third and fourth card are not Big Bazaar. The fifth card is Big Bazaar, but the total amount is 4000 something, which is greater than 1000. Similarly, if you look at it, the orange cards are Big Bazaar, right? So overall, when we look at it, this card fails because it is 3132. This card, it is Big Bazaar and the total is less than 5000. So because of that, we are going to increment the count when we look at this card. So from 0, count will become 1. All right. Any doubt till now?
No.
Is there any? No. I think this is a really easy question. We'll finish this one first. And these blue cards, green cards are not Big Bazaar. Now this is Big Bazaar, but this is not lesser than 1000. So this is wrong. Not wrong. The condition will evaluate to be false. Then these cards are not Big Bazaar. Then we have only one more Big Bazaar. Here this is Big Bazaar and the total amount is less than 1000. So we are going to increment the count again. So from 1 it will become 2. So the answer is 2. Right? I think this is an easy question. So the answer is 2. All right. Okay. Fine. Now before going to the next question, I just have another question which Can you people try that question? So this is the question. Can you people try this question? Hello.
Yes, sir.
Yeah, this is a, see, n and m are positive integer, okay? There are some positive integers. Now the question is, what will x represent at the end of the flowchart? Okay, I've just drawn the shapes randomly. Sorry. In a haphazard way, don't mind. Okay?
Sir, it is x lesser than y, right?
Yeah, that
For
is the
this
condition.
equation term.
Yeah. What will x represent at the end of the flowchart?
X will represent a positive value that's less than y.
That is fine. Like, what meaning do we make out of it?
X will represent how much times
Difference
it is
between
greater
two
than y
numbers.
if it is greater than y.
How much times it is greater than y?
If it is greater than y. Else it will not.
Okay, if it is not greater than y, then what will be here? Something has to be here,
X
right?
and Y's value should be
X and y's value should be
equal.
okay. One person is saying that both x and y will be equal. Okay. Another person is saying that any other thing which you want to say? Others? We just list down whatever you people are saying. One person has told that it has to be equal.
Sir,
Then-
doesn't x represent the difference between both the integers, that is n and m?
No, I'll explain this. Okay, before that, I just want what you people think of it. One person is saying that difference between x and y. Difference between x and y. Anything else? If you people would have observed something about a basic operation which we are doing from our probably third standard, you people could answer this. No issues. Anything else? Just think, okay, you'll be getting it. It's really easy.
Is it the difference between x and multiples of y?
Difference between x and multiples of y. What do you mean by that?
I keep repeating. You have to minus.
Wait, x represents the negative integer, which is the difference between x minus y, because x is lesser than y, isn't it?
Okay, negative integer. Okay, negative integer. What else? You told something else, right? It's a negative integer, and what is special about this negative integer? It's a difference between x and y, right?
Yes.
And one person is saying that it's just the difference between x and y. Another person is saying that x will be a negative integer, and also the difference between x and y. Okay, anything else? Another person told that difference between x and multiples of y. Am I right? Right. Anything else? Really simple question. Just think. Anything else? Okay. You people are all answering in terms of x and y. Then what is the point of m and n? Think in terms of m and n and c.
repeated subtraction.
Repeated subtraction. Yeah, we are repeatedly subtracting here. Okay. That is fine. Anything else? Like, tell in terms of M and N. Can you say something in terms of M and N?
It says how many times n is greater than m.
Okay. How many times M is greater than N? Right? Okay. Right. So do you people want more time, or I can explain what is going on? Can I explain, or you people want to give something else? Hello? Okay, fine. See, whenever there's something like this, if you don't understand what is going on, just try it with an example. Okay, let n be 3 and let m be 5. What will happen? What will be the value of x here?
It will stop, won't it?
3,
No. What will be the value of x here?
3.
3,
3. Okay. Now let n be 5. Now what will be the value of x?
0.
0. Okay. Others, do you all agree with 0? First one, 3 is lesser than y, so 3 is lesser than 5, so x will be 3. But now, do you agree? Do you all agree that it will be 0 when n and m are 5?
Yes, sir.
I don't think it will be 0.
Okay, then what else? Try. Let's say. No issues. One person, few people have told that it will be 0. Any other answer? Hello?
Nothing would be the answer as it means that
No,
x
you
is
are
equal
assigning
to y,
something,
so
right?
it is.
You are assigning something here. This is assignment, am I right?
Yeah.
You are assigning something, so there's going to be something here. What is it? That's the question, right? One person has told, a couple of people have told that it's going to be 0. Anything else is there anything else which is possible? Okay. We'll change this. Let this be 17. Now what will happen?
Two, sir.
Okay, one person has told it will be 2. Anything else?
2, sir, 2.
Okay. So few people are telling 2. Others? Is it 2?
I think so, sir. It should be 2.
Okay. And one Sai Ram has told that it is 1. A few people are also right. Okay. Now what will you do here? You people know that this is division, right? What should I write here? And what should I write here?
3.
3. 5 3s are 15. So remainder is 2. Okay. And we have got 2 here. And 5 divided by 5. 5 ones are 5. And the remainder is 0. And 5 divided by 3. What's the remainder? 3, right? So this is going to give us remainder, okay? See, why is 17? Oh yeah, 17 is not divisible by 5, okay? How do you represent 17?
15 plus
17 is
2.
3. Yeah, 3 times 5 plus 2, right? You people have studied, right? This is dividend, quotient, divisor, remainder. You people have studied, right?
Yeah.
Yeah. So when you observe, the first time when you subtract, first x is going to be 17, y is going to be 5. All right. So first time is 17 greater than 5. Sorry, 5. Is 17 lesser than 5? Is this true or false? Is this true
True.
or false? Just a second.
False.
Just a second. I'll just come. Yeah, sorry guys. So first time 17 lesser than 5 is going to be false because 17 is greater than 5, right? So 17 is greater than 5. So we'll come to the no part. Now x is equal to x minus y. Am I right? Yeah. So then
Yes,
what
sir.
will x become? What will x become now?
12.
12. Right. Now come back here. Is 12 lesser than 17? Sorry, 5. Y
No.
is not changing here. So again we'll go inside. Now 12 will become 12 minus 5, which is 7. First, what you are doing is x is currently it is 12. We are going to subtract 5 from it and it becomes 7. And we are going to assign 7 here. This is what is happening. So now x is 7. Now is 7 lesser than 5? Again, no, right?
No, it's again false.
Yeah. So right now 7 minus 5, it will be 2. So you again come back. Now you check whether 2 is lesser than 5 or not. 2 is lesser than 5, so you will stop. Now what is the value of x? It is 2. So it
2.
is going to give you remainder, right?
Yeah.
So this is iteration, right? We are doing the same thing again and again. Am I right? So when you observe, 17 is nothing but 5 plus 5 plus 5 plus 2. So we are going to iterate 3 times. We are going to go inside and subtract thrice. Am I right?
Yes.
So this is a way to look at division, okay? So this is what basically division is. To multiply 5 by a certain number of times, then you see that you need 2 more to get to 17. So this is what is basically division about. Okay, so is this okay? Everybody clear with what x represents? What the value of x will be at the end of the iteration? If it is signed, then we can move. Is it okay?
Yes, sir.
Yeah,
Yes, sir.
fine. Okay, before that, somebody asked that there's some doubt in 8th question. So we'll go to 8th question, okay? Right. Oh, sorry, this is 10th question. Right. 8th question. So the following pseudocode is executed in the words dataset. What will count represent at the end of the execution? So we are going to arrange all the cards in file 1 first. Then we are going to initialize 2 variables. There are 2 variables, A and count, and we are going to initialize them by 0. Now if pile 1 is empty, we are going to stop the iteration. This is the condition. This is the condition which will come inside the diamond shape. Now if the file is not empty, we are going to execute these things. So we are going to read the first card. We are going to read the card and move the card here. Okay, so in between whatever is happening, it is for a card. Now for a given card, if the word is Monday and A is 0, increment A. All right, A has to be 0. to increment A, what are the two conditions? To increment A, what are the conditions which has to be true? What are the conditions which must be satisfied?
A should be equal to 0.
Yeah, one thing is A has to be 0. The other thing is the word has to be Monday. Right, so these are the two conditions which has to be true. Am I right? Yeah. So two conditions are there. If these two conditions are satisfied, you are going to increment A. All right. Now, if the word ends with a full stop and if A is greater than 0, then increment count. All right. What does the word ending with a full stop mean? We are at the end of a sentence. Am I right?
Yes, sir.
Yeah. If the word ends with a full stop and if A is greater than 0, then increment count. If A is greater than 0, then what does it mean? What are the other possible values for A if A is not 0? That is, if A is greater than 0, then what are the other possibilities of A?
Only one.
Only one. Only one is possible. Because if A is already 1, then this condition is not satisfied. A has to be 0. But now if A is 1, we cannot, and we are not incrementing, by the way. Oh, yeah, sorry. We are incrementing A, but then if A is 1, the second condition is not going to get satisfied. So the only other possible thing is 1. And now if A is greater than 0, that is if A is equal to 1, then we are going to increment count. And after, if the word ends with full stop, we are going to reinitialize A to 0. So what does it mean? For every sentence, A will be 0. Am I right? Let's say there are 5 sentences. At the beginning of every sentence, A will be 0. Here A will be 0 because when we are starting to read the entire cards, we initialize A to 0. So A is 0 here. But after the sentence gets over, A again becomes 0 here, which is what is going to come back here, right? So A is going to be 0 for every sentence. And now at the end of the sentence, we are checking if A is greater than 0. Okay. At the end of the sentence, if A is greater than 0, then definitely Monday, we have seen Monday in that given sentence. Am I right? Yes?
Yes,
Yeah.
sir.
If A is greater than 0, then in that given sentence, we have definitely Monday is there. But is it necessary that it has to be exactly once?
No, sir.
No. Because, for example, I'm just giving some random sentence.
Because
Okay?
Monday will come only when A is 0.
Yeah, no. A is incremented only when A is 0.
Like it only
Not
happens
Monday
when
will come when A is 0. Okay?
A will get incremented only when it is 0 when Monday comes.
Yeah. For example, we have 2 Mondays. We have 2 Mondays in the same sentence. Then the first time when we are going to encounter Monday, A is going to be 0 and the word is Monday. So both the conditions are satisfied. So we'll be incrementing A to 1. Now the second time when we look at Monday,
A is not
A is
0.
going to be
Is 1.
no, at the beginning of every sentence, A is 0, right?
No, sir. Like when second Monday comes in the same sentence, A
Yeah,
will be 1.
when the second time when we look at Monday, A has already become 1 because we incremented it here. So this time we are not going to increment. But then that doesn't mean that there is only one Monday in the sentence. Am I right? There can be more than one Monday. It is just that we are incrementing it only once. So which is why, and after that, after reading the card, we are going to move the card and we are going to repeat the
So
same.
there will be option C, right? Just one occurrence.
Yeah. No, it is not one occurrence. It is at least one. Okay.
At least
Yeah.
one.
Okay. See. Yeah. At least one occurrence is right. Can you all see why it is at least one and not just one? Just because you are incrementing it only once doesn't mean that there is only one Monday. There can be more than one in the particular case, in the particular question. Okay, the person who asked the doubt in 8th question, is it fine? Is the 8th question?
Sir, but I still don't understand why it should be at least one Monday.
Okay. But okay, I just want to know if you understand, if you can see why A is 0 at the beginning of every sentence. Can you see that?
Yes, sir.
Okay. You can see that, right? Now we'll just take some random sentence, okay? A is 0. There's some random sentence. The first word is it. Second word is, yeah, we have it is Monday morning, right? It is Monday morning. And let me write 2-3 words more. And not Monday evening. Just random sentence, okay? No meaning. Monday evening. Right. Now A is 0 at the beginning. Is it okay?
Yes, sir.
So the first word, when we look at it, it is not Monday, so we are not going to increment A. Am I right?
Yes, sir.
For the second word, we are not going to increment A again.
Yes, sir.
But for the third word, the word is Monday and A is 0. That is what our condition was. Am I right? A has to be, A is 0 and the word is Monday. And in between we have AND operator. So now both the conditions must be satisfied for us to increment A. Now here A is 0 and the word is Monday. So we are going to increment A to 1. From 0 it becomes 1. 0 plus 1 it becomes 1.
Okay, sir.
Okay. Now we'll go through the other cards. See, every word corresponds to a card, okay? We are looking at every card. We are going to look at the other cards. And the second time when we look at Monday, the word is Monday. But then A is not 0, it is 1. So both the conditions are not true. And in between we have an AND operator. So overall, this condition is false. Am I right?
Yes, sir.
And only when the condition is true, we are going to increment A. So we are not going to increment A in the particular case. And the word ends. And the sentence ends. And again A will be 0 for the next sentence. But for the given sentence, since A is greater than 0, we are going to increment count. So whether we have now for the next sentence, even if there is only one Monday, still A is going to be greater than 0 and still we are going to increment. So either exactly one word is possible or greater than one word is also possible. So we just, that is equal to is possible, equal to 1 is possible, greater than 1 is also possible. So we combine these two. So greater than or equal to 1. So at least 1.
Okay, sir. Now I
Yeah. So answer is C. That is fine.
understand.
Okay. Now we'll probably go to this flowchart question. Okay. Yeah. Right. Fine. Now see the given flowchart, A, B, C are some different integers. Okay. They are some integers. They are distinct and they are distinct. So no two A and B, B and C, C and A, they are not equal. Now what will X be at the end of the flowchart? Okay. Right. So first thing, we'll go one by one. Okay. First we'll go like this, then we'll go like this, then we'll go like this, then we'll go like this. Okay. We'll go one by one. Right. So first, let's assume that A is greater than B. Okay. Let's assume that A is greater than B. So we'll be coming here. Now an important thing to note is all these things which are shaded in blue, they are going to get executed only because A is greater than B. Right?
Yes, sir.
If A was not greater than B, remember everything is distinct. And if A was not greater than B, then definitely we are not going to come to these branches. And whatever is shaded in yellow, they are going to get executed only because A is lesser than B. Right?
Yes, sir.
Yeah.
So it'll be the second largest number, right? And
Yeah, it is second largest. I'm just explaining. I think most of you would have solved. Now, what is there in now this green part? If this green part is executed, what does it mean? First thing is A is greater than B, which we have already seen, because it is also part of blue. Okay. And now, this green part, there's one more thing which has to be satisfied. C has to be greater than A. Right? Now, if C is greater than A, then C is definitely greater than B. Am I right?
Yes, sir.
So, C is greater than A, and definitely C has to be greater than B, and now that A is also greater than B, so this is how the order is. Now coming here, first thing we know is A is greater than B. Second thing which we know is C is not greater than A. Am I right? Sorry. Yes. One thing we know is A is greater than B. For this to get executed, one thing is, okay, I'll write it somewhere else. For this to get executed, A has to be greater than B. That is one thing which we already know. What are the other things? C is also greater than A. Because the very reason we are coming here is because C is greater than A. Am I right? Now one more thing is C has to be greater than B. That is why we are coming here. So one thing which we can observe is C is greater than both of them. Okay. Now which is the second greatest? Which is the second largest one?
Sir, I have a doubt. Isn't C not
Sorry,
greater
sorry.
than A?
Sorry. Yeah. 1 second. Yeah, sorry, we are coming no, right? So A is greater than B. I just this blue red color thing just what to say? Just fine. One thing is A is greater than B. Now the second thing is since no is here, C is not greater than A. If C is not greater than A, it cannot be equal to A. So then C is definitely lesser than A. Am I right?
Yes, sir.
Yeah. And coming here, S is there. Since S is there, C has to be greater than B. Okay. Now one thing which we can observe is A is greater than B, A is also greater than C. So A is greater than both of them. Now which should come in between? C is greater than B. So definitely it is of this order. Am I right? Yes. A is greater than C and C is greater than B. So this is the order for this. Am I right? Yeah. Now coming here, first thing we know is A is greater than B. Second thing is A is also greater than C. The third thing is C greater than B is false. That is why we are coming here. If C is not greater than B, then C is definitely less than B, which means that B is greater than C. Okay. So combining these things, we know that A is greater than all the two, the remaining two. And now B is greater than C, so it will follow like this. Okay. So from these three itself, you would have mostly found that X is just the second largest one. Right? X is just the second largest one. Anyways, we'll just verify it with this side also. Now coming to this side. Okay. Now coming to this side, first thing is A is lesser than B here. That is the first thing. Second thing is C is greater than B. Right? With these two, what can you conclude? With these two, what can you conclude? Anybody? Hello? Are you all there?
Yes, sir. What's the question?
See, the question is, what will X represent at the end of the flowchart?
Yes, sir.
What
Second
we are
largest.
seeing is what the flowchart basically is there are multiple conditions, okay? Based on multiple conditions, X is assigned different values. For certain conditions, when these two conditions are okay, X is A. If this is okay, but this is not okay, and this is okay, X is C. If this is okay, if this is not okay, and even this is also not okay, this is X is B. Okay, so basically we are just checking, see, based on different conditions, X is assigned different values. But there's something which is common to all the things. We are just finding out what the pattern is. All right. So what I'm saying is, based on these two conditions, we can conclude that for in this particular case, if we are reaching till this point, then definitely C is greater than A and A is greater than B. Okay, that is what I'm trying to say. If we are reaching this particular step, then this is what the descending order of C and C A B C. Okay, is. But then if we are reaching this point, then what does it mean? A is greater than C and greater than B. Am I right?
Yes, sir.
And if we are reaching this point, what does it mean?
A is
greater than B
C.
and C. Right? So we are just finding out, if we are reaching this point, what is the order? That's what we are trying to find out. Once we find out, we can see how X behaves. Right? That's what we are trying, okay? Now coming here, A is greater than B, A is lesser than B. That is one thing which we can see from this. Another thing which we can see is C is greater than B. Okay, with these two, what can you see? One thing is B is greater than A. Another thing is C is greater than B. Combining these two, you can see that C is greater than B and A, right? You can conclude this from this, right? So that is why the state of A, B, C here is C greater than B greater than A. So this is what the order of A, B, C is if we are coming to this point. If we are coming to this point, what is the thing? One thing is B is greater than A. The second thing is, if no is there, then what does it mean? B is greater than C, right? Yes, no is there. So B is greater than C, that is there. And here, yes. So C is greater than A. So we can see that B is greater than...
less than A, sir.
Yeah, sorry. C is less than A, so A is greater than C. So with combining these three, what we can see is B is greater than both and A is greater than C. So this is how the order is. Right? So B greater than A greater than C. Now coming here, one thing is B is greater than A again and B is greater than C again. But since here there's a no, then C is also greater than A. Because it's going to be the opposite of this one. If it is yes, it is going to be the same thing. Since it is no, since this condition is false, it is going to be the opposite of this and there's no equality. Now combining these three, we can again see B is greater than both. We can see that B is greater than both and C is greater than A. Right? So one thing which is common in everything is the value of X is the second largest among the three. Here it is A and here A is the second largest. Here it is C and C is the second largest. Here it is B, B is the second largest. Here also it is B and B is the second largest. Here it is A and A is the second largest. Here it is C and C is the second largest. So that is why option D is correct. All right.
Sir, I have a doubt, sir.
Yeah.
It's in question number...
Which question?
6, sir. 6 and 7.
Yeah. Okay, 1 second. Just a second. Is this question clear first? Is the flowchart question clear?
Yes, sir.
Yes, sir.
Yeah.
Yes.
Then we can go to sixth question. Yeah. Question number 6. Here what you are, yeah.
Sir, I'll just tell what I did. It's given A and B initial is to 1000.
All right.
Then there are if mathematics mark is less than A, which
Okay.
is less than 1000, if to
Yeah.
store mathematics in A.
Yeah.
So it like every mark in the scores dataset is less than 1000.
No. See, it is not like that. A is a variable, right? That is what variable
Yeah.
is. So that is something which you have to understand about variables. Now A
So
is
should we
1000.
add, so should we add it?
No, we are replacing 1000. Okay. Let's say the first card, when you see that the mark is 62. Since 62 is lesser than 1000, what is given here? The store mathematics mark in A. What does it mean? A is storing 1000 now, but we are going to store 62 now.
Okay.
A variable can store just one data type, right, at a time. One data
Yes, sir.
value.
Yes.
Right. So it is going to replace 1000 with 62.
But
Right?
why
We
they
are
given
assigning something.
but why are they given store instead of replace?
It is same. Because the property of variable is such that it can only store one integer at a time. Now, if you are going to store
Okay, sir.
62 here, it implicitly means that you are going to replace.
Okay, sir. Got it, sir.
Okay. You can increment, which is 64. This is fine. But you cannot store two integers, right?
Yes, sir.
Actually, there's a different data structure with which you can store, which you learn in week 5. But as of now, you can only store one integer in a variable. Okay.
Okay, sir. Got it.
Because of that. Now, the next time when you see, let's say the next card is 51. Now we are going to store 51 here because it's lesser than 62. So this is how the minimum works. Okay. Right. So is there
Sir,
any other doubt in?
Sir,
Yeah.
yes, sir. I have another doubt, sir.
Yeah.
It's in question number
Question number
9, sir.
Question number 9. Yeah.
Sir, they asked like how many mistakes is in the data.
Yeah.
Like, isn't the row one also a mistake because like quantity cannot be 4, right?
Where?
Like,
Sorry, which row? Row
first
1.
row. Like it can be kgs or something like that.
No, the unit is not there. That's all.
So like, shouldn't it
This
be
is
same
not
for?
a. This is see. It is not like these are all of same bill, right? Is it given that it's of the same bill? Okay, even if it is in that case, it is implicitly understood, right? There's some bill, some units does not matter, right? It is your business. You are going to generate the bill. It is fine, right? 4 means it's probably 4 kgs.
I mean, what if some other party comes and sees our bill? Won't they just tell this is wrong, something like that? Won't they get
No,
confused?
see, it is your business. You can say that it is our convention. We are just following the same thing. You are asking whether is this legally okay or not, right?
I mean, not legally, but won't we confuse ourselves after some time if you see the bill?
No, if you're having a convention that you're going to store in terms of kgs, then there's no issue, right? You anyway know that it's going to be in kgs.
But they've never given like in the question because I'm just seeing it now.
See, it is just in terms of what to say. It is just in terms of integer, right? Maybe see, whenever there is something of vegetable or fruit category, maybe the billing machine is programmed in such a way that whenever the category is of vegetable or fruit, it is going to be in kgs. Maybe you just enter the number.
Maggie's like the vegetables and food. So like, are they think it'll be 2 kgs?
Or maybe they are programmed it in terms of items. I'm not saying that it's programmed in terms of food or vegetable. Just for an example, I think. Maybe for onion, they have programmed the billing machine in such a way that it will be in kgs. Or for Maggie, they have programmed it in such a way that it will be in units. Depends, right? It's not
You
like
can assume like onion means it's kgs, Maggie means it's a number like that.
it's not for you to. It's not like you are assuming. I'm just saying that there's a possibility. See, in terms of integer, it is 4, right?
Yeah.
We are storing 4.
Yes.
It's not like integer, it's a different data type, it's float. You can have 4.5 kgs also, it is float.
Okay.
Right.
Yes, sir.
So maybe the it can be right if you're saying that the person
I mean, they
the
should have
owner is
they could
going
have
to
given
write
in the
it.
question, right? Like for onion, something like that. Because we
They're
don't know.
asking in terms of data type only, right? The mistake is in terms of data type only, right? Data type and the multiplication, sanity, those things only. No?
Yeah.
Not in they're not asking whether units is given or not. In terms of sanity, it is not. In sanity, it's not like you have to represent the units in kgs or 3 units, one dustbin. It's not like it was not given, right?
Yes.
See, in computer science aspect, it is not an error, right?
Yeah.
That's what we want.
Okay.
Sir, here in the second row there was a multiplication mistake, sir. Like 2 times 85 was still given as 85. So, but
Yeah.
still, if there was another row called total, and the total was made such that instead of 85, they included 170. Like they multiplied it correctly. According to the bill, it will be wrong, but according to us, it will be right. So, should I consider that as a mistake or not?
Okay, you're saying that here they have calculated in terms of 170, right?
Yeah, even the row 4 mistake also they made it right, and then they did it.
Okay, you're saying that here there'll be some mistake and here it is correct.
Yes, sir.
Then you have to, then only row 2 is wrong. See,
Okay.
and if total is also wrong, if total is there in terms of 85, but still total in itself is not wrong, because what does total do? Just simply adds the column, right? The moment you are going to change it to 170, it will change here also.
Okay.
You're saying, maybe I think your question is, here it is 85 and here there's 100. Let's say there are 100, these rows are correct, okay? 100, 100, 100 and it's storing 385. Sorry, 385. But then here it should be 170, right? So you're saying
Yes,
that
sir.
in both the place it is wrong.
No, sir. If the total was 470, but still in the row
Okay.
it is given as 85. So
Then this is
why
wrong. Then only row 2 is wrong. Row 2 is wrong.
Oh, total is correct.
Yeah, total is correct.
Sir, but in the
Okay.
case where the total is wrong, so we should say that the total is also wrong?
See, like, 1 second. I just a second.
Sure.
See, mostly the how is total program is programmed like you add the columns and that will be total, right? Total in itself, there's no error.
Okay,
Only
sir.
because there's error here, it looks like there's an error. But in terms of functioning, this is functioning perfectly fine. That's why it is showing 385. If
Okay,
total,
sir.
if the total here is, if it is not functioning perfectly, then it would have shown something 470 probably.
Okay, sir.
Okay.
So functioning of total is fine, then there's no issue. Only issue is here. Yeah. Anything else?
So like how many mistakes should we consider, sir? If the total is 470 and loss.
If the total is 470, that is if 85 is here and 470 is here. That's what you're
Yes,
saying,
sir.
right?
Yeah.
Then 2 mistakes. Here there's a mistake, here there's a mistake.
Yes, sir.
Because it is computer, right? It doesn't know whether this is true or not. Here it is 85 and I'll add it here. Here there's some other operation wrong going on here. As far as this is concerned, this doesn't know that it is going on wrong over here.
Okay, sir.
Okay, so there are 2 errors here in that case.
Yes, sir.
That is 85 is here, but 470 is here. That case.
Yes, sir.
Okay. Fine. Right. Okay, everybody knows what factorial is, right?
Yes, sir.
Yes, sir.
Okay. Is there anybody who doesn't know what factorial is? I think everybody would have learned it in 11th. So factorial, for example, 5 factorial is 5 into 4 into 3 into 2 into 1, for those who don't know. Just from 5 all the way up to 1, multiply all the integers. Okay, this is what factorial is basically. Now can we just write a flowchart to find the factorial of some number?
Yes, sir.
I'll just write most of the things. Just say what you have to fill in what place. I'll just leave certain things blank. So start, and again integer is some positive integer n. Okay. Fact is the variable. Okay. Fact is equal to n. X is equal to n. Now I'll just stop. Okay, now what can we do? We want this fact. What I'm saying is the variable fact will store the factorial of n. It will store n factorial. Okay. Now what can we do here? And I'll say y x is there. What can we do?
Is x is equal to 1?
If x is equal to 1, okay, if x is equal to 1, you are going to stop. Am I right?
Yes, sir.
Then in the rectangle, we'll write x is equal to x into x minus 1.
Sir, actually fact should be 1, right? Because I'm going to multiply all those and store that value. So fact can be 1.
I'll come. It can be done like this also. Okay, one person has told that x has to be equal to 1. I think I have to give something more.
Yes, sir. So store the next value.
See, okay, x is equal to 1. We'll take it like that. This is not the only way to do it. If x is equal to 1, we'll stop. If it is not, we'll go inside. See, till now what we know, fact should be n factorial, right? What is n factorial? N into n minus 1 all the way up to 1. Right? Now this is okay. Now we have not done these things. Am I right?
Yes, sir.
Sir.
So we have
can we
to
assign
multiply.
another variable, sir? Like y is equal to x into x minus 1.
Then how are you going to do it till all the way up to 1?
Sir,
see, what is x into x minus 1? You're going to find factorial for n. And the variable fact will have your factorial. See, one important property. Now this stop, we must stop at some point, right? This cannot go on an infinite loop. Am I right?
Yes, sir.
This cannot go on. So if this has to stop, and now if x is greater than 1, then what we have to do? Some point x has to get reduced, right?
Yes.
Otherwise, we are going to go on an infinite loop.
And there should be another step.
We can have, or we can do it in one box itself, just for comfort.
Sir, right.
So one thing which we have to do is x is equal to x minus 1. We have to do. Okay, definitely we have to reduce. Otherwise, we are going to go on an infinite loop. Now fact is equal to fact times x. Okay, that's all.
Sir, I don't understand what you've written in the last step.
This step. This is
Yes.
multiplication symbol.
Okay.
Fact is equal to fact times x.
Oh, okay, sir. Okay.
I'll just show an example, okay? Let's say if we are going to find 4 factorial. Now fact is equal to 4. Now x is equal to 4. Now 4 is not equal to 1. We'll go inside. Now x is going
to become 4, 3, 2, and 1.
Yeah. Now x will become 4 minus 1, 3. Okay. Now fact is equal to fact times x. What is fact? 4. 4 into what is x? 3. 4 3s are 12. Okay. Now we'll come here. Now again 3 is not equal to 1. So now 3 is going to get reduced to 2. Now fact is equal to fact into x. Now fact is equal to 12. 12 into 2 is going to be 24. Okay. Now we'll come back here. Now x is equal to 2. 2 is not equal to 1. We'll reduce x to 1. 2 minus 1, x will become 1. Now fact is equal to fact times x, which is going to be 24 times x is 1. 24. It is remaining 24. And when we come here, 1 is equal to 1 and we'll stop. Okay. But this will only work when n is greater than 0. Because when n is equal to 0, for 0 factorial, fact will become 0, right?
Yes, sir.
So for that, we'll do it when pseudocode comes, okay? In week 2 or week 3, we'll have pseudocode, okay? At that time, we'll do it much better. But right now, yeah, this works for some positive integer. Okay?
Okay, sir. Understood.
With this, you people have learned many things, right? Addition, subtraction, multiplication, division. Many things you people would have learned right from your younger age. Just see if there anything else which you can iteratively do like this. For factorial, you can do iteratively. Is there anything else which you can find in this way? Because in computer, you will just give the number and it has to return the factorial. Just see is there any iterative pattern which you can do and try, okay?
Okay, sir.
Fine. Anything else? Is there any doubt? Otherwise, we can wind up. Is there any other doubt?
Giri and myself, Shivagami from the Pod BS team. There are
Yes, ma'am.
two students who have just got the link. They said they have some doubts. They are school students, right? They didn't know, they didn't figure out how to join. I've just passed on the
Okay.
information that this is happening now. In another 2-3 minutes, I think they'll join. They are from the KV Ashok Nagar school. So if you could
Like-
hold on for a couple of minutes, you can clarify their queries as well.
I can hold on, but then like
Yeah,
now I
hello.
have some operational
Yeah.
meeting from 7 to 8.
Hello, sir. Sir.
Yeah, the students have joined, Giri. You can take over. Thank you.
Yeah, sir. Actually, in the graded assignment, I have a doubt, sir. The first question, how should I answer?
No, I cannot give anything about graded assignment. Okay.
Oh, no, sir. Actually,
Only after the deadlines are over, I can talk about.
Oh.
You can guide them on how to approach that sum. I think he says he doesn't have some data set. Where to look
Yes,
for the
sir.
data set, something like that.
Okay, you want the data set? I'll just
Yes,
provide
yes.
the link, okay?
Yeah, sir.
I'll provide the link and you can do it.
Yeah, okay, sir.
It is just the cards given in PDF format.
Oh,
Images format.
I didn't get the PDF format, sir.
The right now I have given the link, okay?
Yeah.
Save it.
Yeah, thank you, sir. Thank you, sir.
Yeah. Ma'am? Hello? Okay, is there any other doubt?
No, sir.
Right. Fine, think about it, okay? If you see another iterative pattern, try to form some flowchart for it.
Okay.
Right. Okay, thank you so much.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah, thank you so much.
Thank you, sir.
Yeah, Ankit, I'm back. Sorry for making you. Okay. Yeah.